everybody. I am so excited to be here. Swadika. What a privilege and an honor to speak to you today and to speak with my heroes. I actually learned about 3D printing from Scott and Jonathan and Jason, so I'm very excited to be here and share the stage with them. And I want to talk to you guys about manufacturing in the extremes. And first, I'm going to tell you a little journey. You know what, actually? I'm going to talk to you about technology. How many here, we had this in the earlier discussion, don't really trust technology or are scared of 3D printing? Come on, we can be honest. Anybody raise a hand? I want to see. Yes, okay, great. So I wasn't alone. All right. So I actually was super anti-tech when I was in college. I went to school for industrial design. And I've worked in underserved communities for over 10 years now, primarily working with communities at the edge. And I like to say that I use Moore's Law's table scraps to aid those at the edges, from disaster survivors to astronauts. But what was funny, I'm thinking about this because what was so funny about being in school was that we had a 3D printer, and I never used it. I never even looked at it because I thought they only made tchotchkes or like little Yoda heads, completely useless items. So I never even looked at it, so it's very funny that I'm here on stage now. How many people remember Haiti and what happened there? Yeah, great. That's just it. Sadly, I think many of you know this, probably firsthand. Once a disaster is out of the headlines, some people are left behind, right? Not only to survive, but how do we help these people thrive? So 2 years after the earthquake, I actually went down to Haiti because I wanted to see what phase 2 of a disaster, what the rebuilding was going on, how that was 2 years after the quake. And I was super curious because I thought everything would be perfect and hunky-dory all over again, right? And I got there, and instead it looked like this, as if the earthquake had just happened the week before. And what I found is I was visiting these hospitals and these clinics and water treatment facilities, and what I found were all these abandoned machinery, right? So these are oxygen mixers just cast away in the back of a TB HIV clinic. Had these been working, they could have been saving lives. And what I found is a lot of these machines were antiquated, and people weren't taught how to maintain them, nor how to get access to spare parts. And what was really interesting is a lot of the time, it was just a screw or a simple washer that could have fixed it. It seemed to me that a lot of aid donations were sent to Haiti, but it seemed to me that it was almost like the money was sent to feel good about sending money, to give people things, but not really to actually invest in the Haitians. And I was shocked by that because they're some of the most industrious, interesting, fascinating problem solvers I've ever met. They make do with what they've got, right? So here's some fun hacks. How are we getting more people on oxygen in the clinics? And oddly enough, I kind of found Haiti to be something similar to space. I bet you guys would have never think you'd hear that, right? It takes a long time to get there. It's very expensive. Things are trying to kill you. Yeah, it's not easy, supply chains there, right? And so what really changed my view on technology was actually this woman here. Her name is Maeve, and she is an incredible woman. She's a volunteer nurse that I met in Haiti, and one night she had to deliver a baby, and she had no medical supplies left because nobody cared about Haiti anymore. It was no longer in the headlines, no money, no supplies were coming in. So when she delivered the baby, she actually needed to tie off the umbilical cord of the infant. And in America, we use umbilical cord clamps. They're very easy little 5-cent pieces of plastic. But she had none left, so she looked for string or a rubber band, but nothing was sterile. So what she did is she actually took her last pair of latex gloves, cut the fingers off, and tied the umbilical cord. It was a great fix. Mother and baby went home, healthy and happy. But what she didn't know was that she would have to deliver 4 more babies that night, barehanded, to potentially HIV-positive women. Oh, wow, I just got emotional. So that was the moment that I thought, something has to be done. This is ridiculous. This amazing woman's life is in jeopardy, all because of a 5-cent piece of plastic. I bet we can use those stupid 3D printers to print those clamps, right? So the next time I had power and internet, I got online and I asked Facebook, does anyone have an old 3D printer? And sure enough, someone did. And a volunteer came down to Haiti and delivered it to me. So I actually learned how to 3D print in a shipping container, hiding from hemorrhagic dengue and malaria. So here's the clamp. After many, many iterations, many, many attempts, finally got it to work. Yay! You know, it was cool. I could help Maeve. But she's not the only medical professional in this situation, right? She doesn't have access to her supplies. And also in Haiti, because they were still so poverty-stricken, many people needed jobs. And so it occurred to me, what if we teach locals how to 3D print and solve problems for themselves? Yes! So here I am, teaching Johnson, a young man from the slums of Haiti. Sorry, let me get some water. A young man from the slums of Haiti in Port-au-Prince who knew nothing about manufacturing or medical supplies. And here he is learning how to use AutoCAD. How many people here have made 3D models? Awesome. Okay, so you guys know how hard it is to learn, especially if you're not used to using a computer. So it was an adventure with lots of learning. But it worked. And what was interesting about this with these 3D printers was that we were actually able to create these pieces for less than it costs to bring them into Haiti. Because we're using such a specific model, we don't have any waste. So the price had come way down. And what was interesting about this was that the initial pricing for these small clinics, because they didn't have access to the Red Cross or the UN, was that they actually had to hire, the donors in, say, America, had to hire someone to go to Haiti with a backpack with all these medical supplies and sneak in as if they were drugs. So it wound up costing over almost $3 per clamp to bring him to these small clinics. And when a woman goes into labor, you need 2 clamps. And the minimum wage in Haiti at that time was $5 a day. So you can see this wasn't really working out, right? Economically, it just wasn't feasible. But after training Johnson, we got the price down to 36 cents. Now, because we were using ABS plastic, basically Lego plastic, we could sanitize those clamps after they were used, grind them up, repurpose it, and make new parts, like nebulizer adapters, right? So it was pretty cool stuff. So we got it down to 17 cents. And instead of waiting months or years to get supplies, a woman would go into labor and you could hit print, and she was ready to go. And here are some fixes that Johnson made on his own. And the best part here is Johnson's now teaching other medical professionals how to use 3D printers to solve their own problems. So it's not really about aid, just giving people things or treating them like victims. It's about trade, teaching them to help themselves and solve their own problems. So let's talk about the world, right? It's pretty cool that we can do these things and we can solve problems in Haiti and here in Thailand, and the world's getting pretty big. We have over 7.5 billion people. Unfortunately, resources are getting a little low. So what are we going to do? We're going to use exponential technology to solve all the problems, right? Unfortunately, yes, it's going to help us, but alone, it's just not enough. We have to remember to keep the humans in the center. So I know some of you are using CAD. How many of you have actually used a consumer-grade 3D printer? One. Anybody? Can you raise them real high? Because I just want to know if I'm all alone out here. Okay, I see 1, 2 hands. Wow. Okay, next time we are having a workshop. Okay? So 3D printers are super cool. They're magic boxes. They solve problems until they don't. And then they look like this face is very familiar for me. So when I travel to crisis zones, I actually bring 2 3D printers, not because I like them, but because one always breaks. So these machines are great, but they're just not quite ready for prime time, at least not in the environments I've put them in. And so to solve problems, you got to be around great people and community to kind of inspire you and learn from. So after Haiti, I wound up meeting my co-founder. We started Field Ready, and we're like, we're onto something. We're going to help people. We're going to save the world with exponential technology. And our first journey was to Nepal. Unfortunately, a tragic earthquake. The roads were blocked. Planes couldn't even land to drop off supplies because there was no gas, so they couldn't fly away again. So what we did when we got there we didn't want to assume that we knew what people needed, right? So we actually went straight to the people who had needs, and we asked them what they needed. And we created it right there. So getting people what they need, when they need it, where they need it. So our process is we identify problems on the ground, we co-design our solutions with the people there so that they actually have a sense of ownership and agency. And it turns out if you co-design, people will actually use the products you create. Yes! And so it worked out really well. And the other part about this is that we would then figure out how to manufacture these solutions there and teach the locals so that they could produce it, reproduce it after we leave. And we'd leave the 3D printers there so they could kickstart their own economy. This is a young man came to us. Phones weren't working, but ham radios were. So how could we amplify the signal? So through different iterations and design processes, we finally made one that was amazing. These are all over Nepal now. And so it's really important to go direct to your customer, or the person, or your user, however you want to call it, right? To really understand what they need so you can create the right things. This is a part of a metal part. It was on a baby incubator. I don't think anyone here would want to put a baby up against that raw metal, right? I certainly wouldn't. So this very expensive, originally very expensive baby incubator was just sitting there rotting in the Kathmandu clinic hospital. So what we did is we prototyped, we fixed a new solution, and by the end of it, we had a stronger part. It cost 50 cents to make, and it got this $50,000, $100,000 machine up and running again. So what is it, 2 hours and 50 cents, and you can get entire clinics up. So this is a water pipe connector. Very exciting, right? Usually, I go to the hardware store and I pick up connectors if I need them. In this case, this is the mountains of Nepal. And so the people who they really needed the water pressure was super valuable. They needed the water because cholera has already been ground, people couldn't get access. So they asked us for water pipe connections. Now, typically, as you saw, we train people how to use CAD, but it takes a very long time, and how to do these processes. But we realized these people in the mountains who'd never used a computer probably don't need to use CAD, probably don't need to spend 90 hours learning how to make water pipe connectors. So what we did is we removed the friction. So I know Jason was talking about generative design, but booyah, we made our own with a couple of college students and some math. We're not a billion-dollar company doing this kind of research. So we made an app. It's called Make My Pipe. Woo! So instead of spending hours CADing out the solution, all they have to do is measure the two pipes, put it in, and print. So I think it's easy to think about how this can be applied in the future. Right? So I think in the future, our plumbers are all going to have like metal 3D printers in the back of their car, so they can print on demand the parts we need. But we don't want them spending too many hours CADing it out, so this way we'll save a lot of money when we redo our homes. So this is in Nepal. An entrepreneur approached us. He was trying to make a stovetop burner, and he couldn't get the angles right. He'd prototyped and just couldn't get it right. And he'd heard about Ram, our lead designer in Nepal, and how he was, I'm going to let him tell you.
A local innovator, Mr. Casey, had an idea of improved cookie stove burner, but he couldn't make it because of the level of complexity in his design. So Mr. Casey was planning to go to India to find a CNC machine to make his new design into a prototype, because no local wooden pattern maker were able to turn his product into a prototype. So when he found field ready with 3D printer in Nepal, then he came to us and shared his design idea, and then we were able to turn his idea into prototype in less than a week. This new cookie stove burner has a better biomass efficiency, so it consumes less firewood and is good for environment, and also it produces very less smoke, so it's good for users' health.
So what's great about this stovetop burner, because it produces less smoke, children at their mother's ankles when they're cooking aren't inhaling all this smoke. And because of the efficiency, Mr. Casey, the entrepreneur, actually won a contract to produce 210,000 of them. How's that for a number, right? So it's pretty cool. He used 3D printing, brand new, well, 30 new years of technology with thousands of years of technology and foundries. So you can use the two together to create solutions. And what I love about it is that that's some real exponential impact, right? So 210,000 homes are impacted by this in a positive way. And each family is around 5. So you can start to see how little tweaks can really impact communities around the world. So what if we had big printers, right? This one is 12 meters tall. It's by a group called WASP in Italy. And they are dreaming of making really low-cost refugee homes. And what they're making is they're using dirt and rice husks to create a binding agent to create homes, right? And as it is right now, this one is about, I think, 48 euros to produce. So I think that's around $52, $54 for a refugee home. And what's really cool about this is that if you get the community involved, most of the cost is actually just mixing up the husks and the dirt itself. So you can bring the whole family in, and they can get involved and build their own home. And then it's a 90% cost cut. So what is that? $5 for a home? Pretty great stuff. He's now building a village in Italy, and there's going to be built-in vertical farms. It's neat to see what we can do, right? This is a 3D printer by Enrico Dini. I think it was the first large-scale printer. And it works like an inkjet printer. So what it does is you have sand, and then it squirts out a picture into the sand with resin. And then you lay more sand on top of it, and you sweep it back. So slowly it builds this kind of sandstone structure. And here it is in action. And there's some other unique applications for this, right? So they're 3D printing, attempting to 3D print coral reefs so we can protect our islands against storms. We can bring sea life back, right? And there's this really great group doing beautiful homes on 3D printing, right? Really aesthetically pleasing. 3 stories. They're out of the Netherlands. It's M-shape, I think. Beautiful homes. Beautiful visions of the future. So with the capacity of being able to print 3D complicated structures like this, you can think about how in the future we're now going to be able to put in our own HVAC, our own plumbing, our own electricity. We'll no longer have to lay pipes inside of our homes. We can design the home to optimize for the wind. We can print solar paint so it'll power itself. We can do that here and hopefully in space one day. But I think I want to bring us back down to Earth. So let's talk about Kenya. So this is a fetoscope. I think that's how you pronounce it. And you actually hold it up against a woman's stomach when she's pregnant to see where the baby's positioned, so you can hear the heartbeat without electricity. Very cool. So then she knows if she needs to go down to a big city to use the hospital, you know? And so Michael thought it was awesome. So Michael lives in Kenya, and he saw our files online. So the other great thing about 3D printing is now that someone else made the file, you can put it online for free, and everyone can use it if they want to. Open source, right? So we're sharing these files around the world. So Michael said, oh, that's great. I'm going to 3D print one, right? Where is it? Oh, that side. So he 3D prints one, and he thinks, well, this is cool, but I actually kind of want to use wood because we don't have that much plastic here. And so he started to create his own. He and Ram are talking, and then between the two of them, across the internet and phones, Ram was able to help him design the right acoustics. And he also was requested by the clinics to make kidney trays. They seem simple, but when you can't get them, you can produce them on demand by going to a local makerspace. So he prototyped the kidney tray, draped it over with plastic, and was able to produce it for 50 cents in a matter of minutes. So in the South Pacific, we're taking all of these lessons and we're putting them into what we're calling a resiliency lab. So the next time there's a crisis, people can activate and help themselves. Here's Abby, and she's actually looking for plastic in a garbage dump because we want the materials so that we can build other things. And here we are fixing early warning systems before the next big storm hits. Right there, teaching people how to produce them themselves. And sadly, do you guys remember Hurricane Maria? That was a much more recent disaster. Has anyone heard of that? The Cat 5 hurricanes? Okay. So we couldn't get there. I was actually deployed on this one. We couldn't get there for 5 or 6 days because all the planes were booked, kept getting bumped. But by the time we got there, we asked everyone what they needed, right? Usually when we get there, they need medical supplies, but this long after, people had already been okay or moved to hospitals. But what kept coming up was people wanted power because they needed to charge their phones to call the mainland. People were actually running their cars with limited gas with one little plug to charge their one cell phone. Pretty inefficient, right? But when you gotta do what you gotta do when you can. And so what we needed to do was figure out how to give them power. And what we kept finding were destroyed solar panels. And what we thought is, what if we can actually fix one small part of this, right? If we can fix one small part of this solar panel, we can create power to help people use phones, to get internet, to get back to rocking and rolling again, right? So we prototyped, we got it to work with an inverter and a car battery. We used duct tape and garbage bags and chewing gum, and gosh darn it, we made power. And we taught locals how to do it. And this is the coolest thing. We actually worked with at-risk youth and taught them how to use the system. So here it is, the first free Wi-Fi charging station out of garbage in the US Virgin Islands. Pretty amazing what you can do with shared knowledge, right? And the best part is, these young men, the next time, unfortunately, there will be more storms, these young men will be prepared. So they'll be able to get their connectivity up and running again before aid even touches land. That's resiliency. So we talked about space, Jason talked about that, and we talked about how hard it is to reach locations. We talked about 3D printing, assembling, sharing knowledge, innovation, some of the hardest to reach places on Earth and off. Syria is a unique situation. We were contacted by these guys, the white helmets. Has anyone heard of them? One? Okay, I'm gonna check. Let's see. 1, 2, 3, 4. Anybody in this general vicinity? No. Okay. So what's happening in Syria is their own government is unfortunately attacking their people and dropping barrel bombs and taking out entire cities. So these guys are real-life superheroes. They see the planes fly right before they drop bombs. They race after the planes, so they're the first ones there. And so when the bombs drop, they're the first ones there to pull people from the rubble. So they contacted us and asked us to help them produce search and rescue tools to save lives for these important times, right? But there's a slight challenge with Syria. It's kind of like we might as well have been working in space because we couldn't cross the borders, we couldn't count on electricity, we had no idea what we could use. So what we had to do is create solutions out of what materials were there. We had to take stock in what was available. This was really our own personal Apollo 13 moment. Has anyone here heard of the Apollo 13 incident or seen the film? Some people have seen the movie. Okay. Basically, the astronauts are trapped. They're being poisoned by their own carbon dioxide, and the filter breaks. So they have to figure out a way to reconnect the filter, a square filter, round hose. And they had to do it in a matter of hours, right, to save lives. And so what they did is they took all the smartest minds of NASA at that time. They contacted the astronauts, and they said, what do you have with you? Primarily duct tape and other parts. And they dumped them all on the table on Earth, and they prototyped and tested until they came up with a solution that would save their lives. And you know what? It worked. So that's what we did. We had to work with them without going to Syria, but we used what we had. So we had phones, we had internet, we had bombed out vehicles, and we had first responder kits. So we were starting to prototype and look. And what they asked us for was a way to lift buildings off of people. Because when those bombs drop, sometimes all you need is 3 inches or 7 or 8 centimeters to save a life. So that's all we needed, was just a way to lift that foundation just a little bit. So we started creating bladders, these really strong balloons, right? And the innovation came from, you know what we had? We had these bombed out army vehicles, right? And on top of them, have you guys seen them? They have canvas on top to kind of catch shrapnel, protect you from the sun. And we took that off and we cut it up. And we had to figure out how to get it together, so we heat welded it. That means we took friction, put it together so it would create such a strong bond, it would create a really strong balloon. And we used the air tanks from the first responders to inflate those balloons, so it was really strong. And it worked, and it was lifting things, until it didn't, because they kept bursting. We're like, we're so close. Why? And so we had to think again, like, what's available? We couldn't go there, we couldn't look, so we had them take pictures and send us the materials. And it dawned on us. In the back of your car, you all have mud flaps, right? Like those little mud things keep the dirt out. And they're flexible, right? So we took them and we put them over the balloons, and all of a sudden, we had really strong, inflatable devices that could lift buildings. Now, the interesting thing about these airbag lifters is that in the neighboring country of Turkey, they were $5,000. These we were able to make in a war zone for $50 in parts. Here's Usama, our team lead. Here's the scraps. This is the whole kit. Would anyone like to see how it works? Yeah? Okay. I was hoping you'd say that. So, did I tell you that these bad boys can lift 9 tons? Never let a good crisis go to waste, right? How can we innovate with what we have? This is our lab in Syria. You would never know that there had just been an airstrike. You know why? He's so excited? Because he's manufacturing solutions for people in his own country, and he has purpose, and he's saving lives. They've created over 200 of these systems. They've been distributed around Syria. They've been saving babies and mothers. I'm super excited about it. And what's really cool about this, because everybody can share with the power of the internet, and we can share CAD files now and ship them around the world for free in an email, right? They are actually teaching our Nepali team how to produce these airbag lifters so that they're prepared for when the next big earthquake comes. Pretty sweet, right? So taking something from a war zone and being able to use it to save lives in other situations. We're hoping to get these around the world. So in closing, it's really about prototyping, testing, finding solutions, asking what people need, knowing that sometimes you never know what's going to happen, so bringing with you the tools to solve problems, sometimes a 3D printer, but most importantly, your mindset and how you look at things. Because so many times people give up when it looks like there's no hope. And it turns out there's always a solution. You just have to look harder and ask for help. And to be successful, you really need to know the people you're creating solutions for or products. And be able to share, because we manufacture, because for me, manufacturing, I don't know about you guys, but it's about solving problems and creating delight. Otherwise, why are we doing it, right? So it's also about sharing these answers and spreading this around and helping people help themselves. And going directly to the people there. We don't need to store things anymore. We don't need to ship things around. We can start having impact right in the moment. And so what I want to leave with you is that sometimes this kind of hyper-local digital fabrication can actually be cheaper, faster, and better for communities at the edges. And so I want to leave you with this thought. With adapting technology and actually keeping the human at the center, you can create real, life-changing results. Thank you.